Hello, hello. Good morning, Jessica. Thank you. Awesome. Good morning, Jessica. Good morning, Gil. Good morning, Gil. Good morning, Sue Lady. Good morning, Nora. Good morning, Samara. Good morning, Loreni. Good morning, Nicole. Good morning, Jin. Good morning, Dewan, whose name I think I'm still mispronouncing, but you'll tell me. And I apologize. Good morning, Ashley. Good morning, Christopher. Awesome. I love this part. I love this part. And so you know that, well, it doesn't matter. Okay, it doesn't matter. Hello, hello. I'm going to miss you guys next week. Good morning, Jason. More people coming in. Good morning, Jason. Okay. And we will start in a second. Okay. And just a reminder, more people coming. Good morning, Ria. Good morning. Good morning. Okay, I'm just going to reminder in the chat. Okay, good morning, everybody. I'm just reminding you in the chat that assuming all goes according to plan, you should be back live for real in Westport this coming Monday for the next class. Wait, we do have school. Wait, do we have school this Monday? We do have school this Monday, right? Tell me if we don't. Am I crazy? We do have school this Monday, right? Let me know if I'm wrong about that. But assuming we have school this Monday, that's not a high. I get all the February holidays confused. You're back live in Westport with Professor Walters, Professor H. Walters. She's on her way back to the country. Everything should go according to plan. Of course, there's always a small possibility that something goes awry, in which case just look out for notifications in Google Class. Like you're going to continue with the same Google Classroom system and all of that. So if something should go wrong, I will notify you over the weekend and I'll make sure to get confirmation that you got it. But if you don't hear anything, assume you're back in Westport as of Monday. And I will still be in the background, missing you and be in the background for questions or confusions as they might arise. But okay, but right now we're going to continue. Again, please stop me at any moment today if you have any kind of question or anything. Don't think of it as an interruption. Think of it as a participation. But if there aren't any questions or whatever, and I'm assuming you can hear me, right? Maybe someone put in the chat, can you, I just lost, sorry, just lost my, yes. Okay, thank you, Nora. I appreciate it, but I just lost my, not but, thank you, Nora. My board just gave out. I don't know why. Hold on one second. I'm sorry. Okay. Okay, we are, there's a little bit of an, oh, and this is the wrong, pardon me for a second. I'm sorry. Don't, that screen right there is the wrong screen. Okay, the correct screen is coming. So my screen, my whiteboard is like on some sort of, what's the word, delay, but what's the word for video electronic? Oh my God. Well, anyway, it's on a delay, sorry. But okay, so we're gonna get back to, the number line sheet now. We're going to continue going over the number line sheet. Again, please stop me with any questions. Also, as far as homework and all of those logistics are concerned, here's where we are now. I believe you've had like 3 game turn assignments, and then there's a 4th one, for this 4th class due tonight at midnight. Of the 3 game turn assignments you've had, I believe that I've returned 2 of them to any of you who turned 1 in. If you didn't turn 1 in again, you still sort of can, because we're all getting to know each other now. They're not obligatory, but they are for points. So you never have to do them. And hopefully Professor Walters will continue the system, even though it's not a Zoom class anymore. But anyway, but I'm going to pass the points on to her, of course. So what I'm just trying to say is, with the game turn assignments, you've been given an opportunity to turn in 3 thus far. I believe if you've turned them in, you would have gotten back 2 of them, the first 2. If you turned in a third, but you haven't gotten it back yet, that's on me, not on you. But if you did, but you should have gotten back the first 2 if you turned them in, and please check and let me know if not. And as far as the actual homework number line that was due, I have not turned back any of those. We're still working on it right now. That's on me, not on you. I apologize. There's a new homework that has been posted, that was just recently posted, that's due Monday. Couple things about that. Hopefully we're going to finish the number line assignment today, hopefully, going over it. Even if we don't, and Professor Walters picks up where we left off on Monday, then technically the average speed, the very next homework, is technically due Monday. Just like with the number line assignment, you should, based on just what we're talking about in this number line assignment, and based on a definition that is repeated for you in the sheet, in the homework sheet called average speed, you don't need any other outside knowledge or outside background or any outside reading or anything in order to do homework 2. I'm not saying it's easy, but I'm saying it is entirely based on knowledge that we have established here or will have established here, and or is written in the sheet itself. Let me repeat. So please do try to do it for Monday. Even if we haven't finished going over this, please try to do it for Monday. Please greet Professor Walters with being totally caught up in class. I'm going to be even more specific for a moment. Again, it is always true that you you're encouraged to consult any sources you ever want to on the web. You know, Khan Academy, 3 brown, 1 blue. That's all good prior YouTube videos from this class. You're always welcome to consult any sources you want to do homework, and you're very welcome, very encouraged to work with one another on homework. That is not cheating. That is a good thing. Okay, just to remind you, just to be clear, and all of that is true as far as Professor Walters is concerned as well. All of that is okay. I don't really think you need to do any of that for homework 2, to be honest. Like, I think you should be able to do it just based on what we're talking about in class. To be further honest, the first question on the sheet is called warm-ups or something, and they are just that. They're essentially plug-in chugs, but use them to practice our 5-step method for solving problems, please. Then I'll warn you, the next 2 questions look very simple. They are simple. The next 2 questions on the sheet, they are simple. Like, there's not necessarily a ton to do or something, and they're entirely based on the definition for average speed, which we're going to reestablish today. But I'm also going to warn you that even though they're simple, they're also easy to get wrong if you don't think about it very carefully. My big hint for question 2 and question 3 on the homework that's due this Monday is it's all about the definition of average speed, which we're going to reestablish today in class or re-practice. The definition of average speed, I'm going to say right now, well, I'll write in a moment, but I'm going to say right now, the definition of average speed, which is a particular kind of speed, but the definition of average speed is total distance traversed divided by total time elapsed. It's distance over time is what average speed is. That's the definition. And just a little warning. Oh, sorry. Yes, I am. I'm sorry. Oh, yes. Yeah. Oh, Christopher question. Sorry. Wait. Well, everything I'm saying right now, I'm sorry. I'm talking about a new homework that was posted. Well, maybe you can confirm or deny in a minute. If you check in Google Classroom, I believe I posted a new homework about an hour and a half ago or something. I don't expect you to have done anything with it yet. I don't. And I don't even, okay, cool. Thank you, Nicole. Thank you. And I don't expect, oh, sorry, wait. Oh, well, yes. Oh, okay, sorry. So backing up, good question in the private chat. So let me just, okay. So right now to everybody, I'm just sort of giving you there's a new homework that's posted for Monday. I know you haven't gotten back the first homework yet. And I know some of you are still working on the first homework, and that's fine. And we're going to spend the rest of today's class going over the first homework. We hopefully will get to the end of it. But even if we don't, you'll certainly get all the main ideas in all of that. And then if you haven't done it at all, or you want to revise it, please do. But I'm saying, yes, there's a second homework due Monday. I am saying you should all do it before you come into class Monday, before you meet Professor Walters and all of that. You should do it. And I'm not saying you should have done it already. but I'm saying you should do it for Monday. And I'm saying you would be able to do it even just right now, based on the knowledge you have in the class right now. Like, it's not really new material. It's a new expansion or extension or application of this material. You would be able to do it right now based on what we're going to say in class and what's written in the. Yeah, thank you. Good. Thank you, Gil. Yeah, I think it is straightforward. It is not meant to be super stressful. It won't take you very long. Again, it's an opportunity to sort of practice writing out all your homework, doing the 5-step problem solving method, blah, blah, blah. It's an opportunity to come in and sort of show Professor Walters that you're really on top of your game and give her something to work with, all that. But I am also warning you all. And then I see the direct chat question. It's a good question. I'll answer 1 second. But I'm also warning you all that what it's really a practice in is taking definitions super seriously. I'm telling you right now that the good news is the only thing you really need to do the homework. And again, if you're bored right now, feel free to like privately start it. That's fine. But after the warm-up questions, the second and third, they are straightforward. They're not complicated. I don't mean they're easy, but they're not overly complicated questions. And I'm telling you right now that what you really need for them is the definition average speed equals distance over time. In a way, that's all you need for those questions. And that's the good news. But the bad news is I am warning you, don't use other things. They're about how seriously can you take that a lot of people, without even realizing it, start making up other definitions to solve those problems. Like definitions that seem reasonable. They unconsciously, they'll think, oh, average speed is the average of speeds or something. They'll start taking speeds and averaging them to make average speed. And I'm just sort of warning you right now that the questions are not meant to be tricks, but they are a little bit kind of traps. They are to encourage you to, one way or another, just use the definition average speed equals distance over time. If you find yourself trying to compute average speed in any other kind of way, even a way that sort of seems to make sense to you, you may actually find the questions easy, but you may easily end up getting the wrong answer. So they're slightly trappy questions, okay? But also just please everybody remember, even if you get the wrong answer, you still can get full credit for the homework. And in fact, this would be our first example of seeing that too. If you do out the method and you do it the 5 steps and you show all the work, you can get full credit and will get full credit for the homework, even if you get the wrong answer. So don't stress it. I'm just saying it's a little bit dicier than it might look, but it is straightforward, yes. And so please do that for Monday and, submit it to Google Classroom, blah, blah, blah. Again, Professor Walters and I will continue to share this Google Classroom. I'll continue to see what's going on in case there's concern. And she, blah, 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 blah. And we're in communication. Now there's a question and we're going to start in a second, but there's also, and keep these questions coming. Again, the more you're talking to me or one another, the better. Direct chat question. Safe to say that, so I'm not saying the name, but it does say in the direct chat. So it's safe to say that the first exam will be on the number line and average speed, et cetera. Well, yes, there'll be more on it than just these 2 sheets. But yes, this type of material is what the first exam will be on. Technically, this material that we're in right now, this topic, this chapter, if you ever looked it up in a textbook or on the web, this chapter that we're doing is technically called One-Dimensional Kinematics. I should write that again in a second. I will. One-dimensional as in line. Kinematics means motion, but everything in physics is motion. Technically, kinematics means where we're defining our terms of motion. And everything we're doing now is ultimately about displacement, velocity, and acceleration. We haven't gotten to acceleration yet, but that's like the world of stuff that we're doing right now, defining those terms and applying them and developing equations from them. Ultimately, the first exam, just so you know, because someone asked in the direct chat, the first exam is ultimately on all of this stuff, which ultimately means the first exam is really on all of the equations, problem solving implications of constant acceleration. There's ultimately 8 big equations that we care about by the time you get to the first exam. But yes, so there's more than just this, but yes, this material is on the first exam. Yes. Okay, cool. Again, stop me but I'm going to start. So I'm going to go back to the sheet now. And last thing, hopefully you saw or see, again, every class we've had so far, any notes I've done on the screen, on the whiteboard, hopefully you saw a PDF of it was plopped into your Google Classroom. You can tell me if that's not the case, and they're called class notes. And then hopefully you saw, I believe, a recording of so this is our fourth class. The first class wasn't recorded. So you should see there should be 2 recordings of the 2 last classes on YouTube linked in your Google Classroom. Obviously, we're getting meatier and meatier with the material. There's not that, you probably don't need them, but hopefully you can confirm that they're there. And same thing today will be posted for all, same thing. All right, so so stop me if I'm just gonna start here. Okay, and I'm going to I'm just going to summarize what we have so far. Okay, just to remind you, and again, I don't think anybody had any problem for this, but just to remind you, distance right now means total space traversed, total amount of space that something travels, making no distinction between one direction and another, right? So when you want the total distance that something travels, you add up all the chunks of space that were traversed, and you don't care whether the space was traversed that way or that way. You just add up all the chunks of space. That's what distance is. Notice my definite, and I'm defining distance with a triple equal sign. I don't remember if I wrote this down or not for you, but I'm telling you again, we use triple equal signs to mean defined as or defined as. So, and now notice also that distance, which is a sort of informal, qualitative, kind of less scientific concept, I'm just defining in English. It's an English concept. I'm defining it in English, and we're going to use it, but we use it in English. Then we define the slightly more sophisticated, more precise scientific concept called displacement. Now, really, in English, displacement is distance taking into account direction. And remember that we're in one-dimensional space right now. Everything we're doing is one-dimensional kinematics. So we're assuming that we're on an axis of space, like a number line. We're assuming that some spot on that axis has been designated as 0 by the user, by the researcher, by the physicist, like somewhere on that number line has been chosen as spot 0. Everything to one side of that 0 has been designated positive, and everything to the other side has been designated negative. Like that's the world we're living in now. That's our coordinate system. And so, and then all the spots on that number line are labeled with a variable called X, right? I mean, that's what we said last time. And in the background, meanwhile, we have time flowing. Time also is like a line. It begins with a place called 0, which is wherever the user or the researcher has started his or her stopwatch. and everything to one side of that zero is called positive t values. And frankly, by the way, everything to the other side of that zero is also called negative values. They don't come up as much, but they certainly can come up. Anything that happens before the experiment would be a negative time, for whatever it's worth. And so we say now, we start getting mathematical, and we say displacement would be any current position minus any initial position. It's the literally displacement means how much something was displaced from then to now, but taking into account, accounting for direction, and directions designated with positives and negatives, right? So displacement gets us a little bit more mathematical and more quantitative than distance. And it is from here on in x minus x naught, right? Just using the notation from last time. Just trying to summarize where we're at. So I want to make one more, I'm going to go back to the sheet and continue to solve the questions, but I want to make one more sort of notational note or lecture-y concept here for you, or two more notes. I'm going to say now, from now on, and you may, again, this might be familiar to some of you. Okay, so note, again, this may be old news to many of you from high school, but I want, from now on, distance it is part of a larger category of quantities or measurements known as scalar quantities or measurement, scalar measurements. A scalar measurement or a scalar quantity is a quantity that is just a pure number, a pure size. That's what distance is. Temperature, by the way, is another example of a scalar quantity. Like, temperature doesn't have direction. Temperature just is an amount. Whereas displacement, from here on in, we're going to refer to displacement as a vector quantity. A vector quantity is any quantity that intrinsically contains both magnitude and direction, like as a package. A vector quantity is one that is a measurement that includes and takes into account and conveys both size and direction. So displacement is an example of a vector quantity, whereas distance is more, even more specifically, you could say that displacement is, you could say that distance is the magnitude of the vector quantity displacement. In other words, displacement, all vector quantities sort of contain two pieces of information at the same time, the size and the direction. The size piece is usually itself designated that is the scalar piece of the whole package. So distance is the scalar magnitude, the raw size, almost like kind of, you could say, the absolute value of the vector quantity displacement. Ultimately, in physics, we're very concerned with vector quantities, with these precise measurements that account for size and direction. But the size of every vector quantity is known as the scalar magnitude. Therefore, I'm going to tell you one more thing now. I keep alluding to it. I mean, I've alluded to it 1,000 times. I'm going to say it formally now, and finally we'll get back to the sheet and keep going over it. I'm going to say, Okay. Now, so just to summarize where we are right now. Now, and I'm tending right now, it's tending to look like scalar quantities are written in English, vector quantities are written mathematically. That's not like a rule. That's not necessarily always true. What we're really trying to always do in physics really is kind of transition or translate from concepts that are in English or whatever language in our mind. We're always trying to translate them and symbolize them mathematically. One thing I want to emphasize to you is that everything that's in math is a symbolic translation or symbolic abbreviation of concepts that we should be able to hold in our mind, either as English or as pictures or something else. Like math doesn't just stand on its own. Math should never say something that doesn't make any sense at all other than mathematically, if that makes sense. But the vector quantities are more precise, more quantitatively rigorous and rich, and ultimately more useful in physics. So I'm tending to turn them right now into mathematical symbols and equations more than I'm tending to turn the scalar quantities. What I'm trying to say right now is that we had distance, the scalar quantity, and then the vector version of it was displacement, x minus x naught. Then I'm going to say now, well, what if you ask how far something has gone per unit of time, and I like if we're talking about units, well, yeah, if you ask how many meters or feet or something traveled in or per a certain number of seconds or hours or minutes, or whatever, and you take that ratio and just divide the total amount of space traversed by the total amount of time elapsed. That ratio is what we call average speed. It's not the only kind of speed. It's not necessarily how fast something went at any given point, but on average, it's how fast something went. We call that, that's what fastness is. It's how far you get in how much time. It is the relationship between space and time in simplest terms. Well, if we go, well, the vector equivalent of that is if you take displacement and you put it over time, you get what we call average velocity. So just note, just to be as clear as possible, the second homework sheet is all about average speed. That is, you have to practice this ratio and practice taking the ratio seriously. But in the second homework sheet, the one that's going to be due on Monday, direction, direction doesn't play a very big role in what's going on. You don't really have to track minus signs and plus signs. You don't have to distinguish them in the second homework sheet. The second homework sheet really is all about average speed. But in this first sheet, we're sometimes dealing with average speed, but we're also comparing it to the vector quantity, average velocity. Average velocity, just I'll say this and we'll move on. If you're following what I'm saying so far, and I think you are, I'm guessing, average velocity is a vector quantity. So just like displacements, average velocities can be positive, zero, or negative. There's no contradiction or no problem with saying that something is having an average velocity of -9 feet per second or something. That just means it's going at a certain rate that way rather than the other way. The negative sign in velocity is just telling us which way things are going. Okay. All right. So I think that's, please stop me if you have any questions. I'm going to go to the sheet now. I'm going to let me know if you have any questions. I'm going to turn, I would even, are we good for me to, can I turn to the sheet back to where we were? Yes. Can I just get some confirmation or great. Thank you, Jessica. I appreciate it. It means so much to me. Thank you, Jessica. All right. Awesome. And thank you, Nora, before, and thank you, Chris, before. Okay. All right. I mean, thank you. Well, yes. Thank you, Nora, before, but also thank you, Nicole, before. Okay. So returning back to the sheet. And I believe we're on question 2, strangely. Oh, no, we did question. We're on question 3, I believe. Stop me if I'm wrong about that. So, okay, back. Okay. 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 So I'm first of all, so I'm doing the thing, right? I'm doing Well, all right. No, I'm trying to, okay. I'm trying to, again, be a student or show you what I'd be looking for you. So first I'm doing DFP, diagram and fact pattern, but we've already, presumably you're just continuing. This is a continuation of what we did Monday. So we've already drawn the diagram and the facts way above. They're applying the same way to all these questions. So I don't have to redo it every time. I'm just literally writing for diagram and fact. Please see above. Like you could do that as well. That's DFP. You don't have to write DFP, but that is DFP step 1. So now I go to step 2, which is what is the question? And in fact, I have to switch my screen. Hold on a second. Sorry. Yes. Okay. So now I go to, this is question 3, right? Sorry. Oh yeah. Okay. So question 3 is, okay, so for t equals, so I wrote the question. Again, you can make it even faster than that. You could just say compute AS or something. Again, mostly these questions, as they get more into equations and stuff, you could just write like, if there was a symbol for average speed, you could just write that, whatever, but that's the question. So that was step 2, WIQ. Now I do step 3, GDP, general definitions and principles. So I literally write down, even if you think it's a waste of time, and I apologize, but I write down average speed equals distance over time, like before I even apply to this question. That's my step 3, right? And you can write, again, if you want to write in the margin, GDP, you're welcome to. If you didn't write this down, we would write that and take points off. Okay, blah, blah, blah. So average speed equals distance over time. Now I'm doing step 4, particular application and work. Like now I'm doing the plug and chug part. Now I'm actually going to apply the numbers of this problem. I could even drag it out a little bit if I could do this. I could say the distance we already established was 21 feet. Like we got that from question 1. We could even say that. We could say from question 1, you don't have to, but, and the time is almost obviously 8 seconds. I guess nothing is obvious, but, and so the average speed equals 21 feet per 8 seconds. Just notice this little subtle thing. Notice in my step 3 GDP, I had a triple equal sign, average speed, triple equals distance over time. Now I have average speed, double equal sign, 21 feet over 8 seconds. That's a subtle difference, right? The difference between what average speed means always in general versus what it actually happens to turn out to be here. Notice also, like, even if you're getting this problem wrong, you would still get the first part right. You get my point. Okay, so that's that. Now I'm in the last step of final answer circled. And you can do this a number of ways. Frankly, you could leave it as 21 over 8. That's fine. I know it's a top heavy fraction. I don't care. Or you could do something like this. I always get this. Sorry. Or you could do, right. And the reason I went out to all 4 significant digits just because I'm not rounding. The fraction actually does stop there. So I don't see any reason not to, but we're not too fussy about significant digits in a context like this, but that's my final answer circled. That's the answer. I mean, that's the answer to the question. And again, I just did all 5 steps. So, and again, you might've done that in your head, but that's the work that I would show to do it. Okay. So that's question 3. Please stop me can I just get confirmation? Is that okay? Question 3. Can I move on to question 4? Can I get any confirmation or not? Thank you, Gil. Totally appreciate it. Well, like the sir. Oh, hey, all right. Okay. Thank you, Jason. Thank you, Nora. Totally appreciate it. All right. Awesome. And I think Jessica, thank you, Jessica. I'm getting the chat is becoming like a whole stream of weirdness to me, but okay. But thank you. All right. Awesome. So I'm moving on to question 4. And question 4 is, okay, of course. Okay. So question 4, again, diagram, see above. And I'm even going to say now, see above. And for all remaining questions, you can do this too. We're not trying to make The thing is, for a lot of problems in physics, the diagram or the facts would be changing all the time. So, but okay, it's not here. Okay, so that's the diagram. Now the question we definitely need, the question is, sorry. Right, so this is the question now. What's the average velocity for the entire 8-second journey? And we have a symbol for that, v with a bar, but so there's no reason not to use it. We just don't really have one for average speed. That's why I was keeping that in English. But okay, so we're solving for v bar now for t equals 0 to t equals 8. So again, we do first we do triple equal sign, v bar equals x minus x2. And this is our one and only equation so far. Obviously, things are going to speed up a little bit as they speed up. We have that. And we know that x minus x naught, we already solved for it in question 2 or something, and we know that t equals 8. So v bar double equals sign -9 feet over 8 seconds. You honestly could leave it like that, whatever sort of makes the most sense to you. But I'm going to leave it like this. But you definitely do want to include units and all that in your work. So that's my final answer for that. And stop me if it doesn't make sense. But now, no. So things are starting to get a little bit like this is starting to look a little bit more like physics. I hope. I think it's starting to get a little bit more interesting. Maybe like, I mean, it's not a big deal to plug and chug again. I'm aware of that. But one thing, just note, my final answer for average velocity is a negative number. Now that, right, my average velocity, my average speed was not. Also notice they're two totally different numbers. Like average speed and average velocity are ultimately different things. The average speed was like 2.625 feet per second. The average velocity is -1.125 feet per second. First note, they're two different numbers. Second note that the average velocity, it isn't always negative, but it can be negative. Average speed will never be negative. And by the way, if there's any motion at all, I don't think average speed's ever going to be 0 either. Average speed, if there's motion, average speed is going to be a positive number. But average velocity can be negative or 0. So one thing you might even want to write in your notes, or just if you're tracking this, note that for a given situation, the average velocity is always less than or equal to the average speed. It's never greater than, if you think it through. The average velocity is always less than or equal to the average speed. The average velocity can be negative. It can even be 0, as we'll find out later in the sheet. Notice, please, even if you've done this a million times in high school, notice when the average velocity is negative, that does not mean anything weird or psychedelic or bizarre. Like physics can get all super interesting and cool, like black holes and going back in time and stuff that I ultimately totally care about and believe in and would like to ultimately discuss with all of you by the end of physics 204 or something. But that's not, we're not saying anything weird right now. We're just saying that the thing on average has a certain rate, and that on average, the thing was displacing to the left rather than to the right. That's all the negative sign means. It doesn't mean back in time. It just means to the left rather than to the right, or to the south rather than to the north, or whatever. So velocity is as though if you were driving a car, if you were to have a velocity-o-meter in your car instead of like most cars have a speedometer, they have a speedometer, a speedometer. If you had a velocity meter, it would be like your speedometer hooked up to a compass, and just that whenever you started going south rather than north, it would go into the negative numbers or whatever, right? Okay, I think everybody gets that. But all right, so that's the answer to, but stop me if you don't. But that's the answer to question 4. So now I'm going to go on to question 5. Again, please stop me if we're starting to make tracks here. Okay, question 5. I have to remember what it is. Question 5. Oh, hello. Oh. Okay, question 5. Okay. So question 5, we already did the diagram. Now, this is the exact same type of question as question 3 was. We're just starting to drum in now. We're just trying to emphasize with this question, like, okay, average. In fact, I'm even going to say to you, this is like to you as a class. Sorry, hold on. Okay, quick sidebar, kind of a sidebar. We're now about to ask like the same question that we asked in question 3, but we're going to ask it for a different range of values. Like we're going to ask average speed again here in question 5. But now this time, instead of asking the average for the entire thing of 8 seconds, we're asking for the average for just a particular sub chunk of 5 seconds. In other words, we're really taking seriously the idea that what an average is, what an average value of any kind is a value that refers to a particular range or region or segment of values that occur between 2 points in space and time. And that whenever we measure an average, it's very, very important and crucial to be explicit about what our particular range is. The average from here to there is different from the average from there to there. Just like your grade in the class, like you have an average at the end of the whole semester, but as you're progressing through the semester, you have an average for the first quarter, you have an average for the first half, and the average keeps changing. So an average is a value that represents an entire range of values between 2 points in space and time. In space and time, because we're talking about physics. Sometimes we measure averages to represent a range between 2 points. Sometimes we measure quantities literally at 1 point. Like sometimes we're talking about a range between 2 points. Sometimes we're talking about a value literally at 1 point in physics. We do both. Right now we're emphasizing the average thing, but it's really important in any given moment in physics to know which one we're doing. Are we getting the average? Are we looking at a range between 2 points? Or are we looking at a value at a point? The reason this is a big distinction, I sort of wrote in blue at the bottom of the sheet, is anything that's not called an average value is generally called an instantaneous value. Like we're talking about average speed here and average velocity. We will soon have a concept of instantaneous speed or instantaneous velocity, which would mean how fast we are going at a particular point in time and space. Now, you might even think it's weird that we're going in this order. You might even think, why didn't we just start with that and then go to averages? Like, why are we averaging before we even? The reason is an average value between 2 points is actually far easier to measure, observe, picture, and compute than a precise, like it turns out it's a little bit more difficult and weird to know exactly how fast a car is going at a moment. It's a little weirder and harder to picture how fast a car is going at 1 point in time, because after all, if fastness means how far do you get in a certain amount of time, well, at one moment of time, no car or no person ever gets anywhere, right? At 1 point in time, you travel 1 point in space. So actually figuring out how fast you're going is like a little bit of a weird head trip. It's ultimately called calculus. So knowing what is happening at a point is certainly ultimately more precise. And ultimately, we certainly care about it in physics. Knowing how fast something is going at a point in time or space is indeed more precise and maybe even more ultimately useful in physics. However, it is very difficult to picture, observe, measure, and compute. So averages are less precise, but they are easier to picture, observe, measure, because we just like an average is just like, how far did you get for this range divided by how much time elapsed during that range. So we're starting with averages, and not because, by the way, last thing, when I say we're starting with averages because we're easier in those, I don't mean because you're dumb students or something like because you're not dumb. And I don't even mean it because you're students. I'm not saying we're baby stepping this because like we want to be fair. I'm saying that's the way physics works. All physicists always proceed from what is simpler to what is less simple. That's the art of physics, is ultimately trying to simplify the world. So, I mean, this is okay. So physics is constructed first. The first foundation of it is like these average quantities. And then from them we extract, and we will later, the instantaneous quantities. But anyway, so, okay, so that's what's going on. So if average quantities are very important, then what's part and parcel of them is what is the range of values that we're averaging. So now we're going to practice that by looking at a different range of values. Okay, and I don't think the math is going to be hard to you, but I'm just explaining. All right, so back to the question. So back to the question again. Stop me if you want me to. Okay, so we're saying average speed equals, again, distance over time. Again, same definition as before, but now, well, okay, so clearly here now the time is 5 seconds instead of 8. So it's important for us to be consistent now and ask, okay, so we're going to divide by 5, not 8, but we're not going to just divide that same 21 number. We're going to look at how much distance was actually covered in those 5 seconds. Well, I believe in those 5 seconds, first he goes, well, I believe it's this. Right, I'll check the sheet in a second, but right, I believe in those first 5 seconds, the instructor started at 4, he went to -2, so he went to the left 6, or something like that, and then he came back to the 4, so he went 6, and then he went 6 again. But we're talking about distance, so all we care about is the absolute. Please correct me in the chat if I'm putting the wrong numbers here, but I believe I remember this. So I believe the total distance is 12 feet, the total distance, right? So, and again, please correct me if in the chat if I'm wrong. But I believe the average speed here then is 12 feet per 5 seconds, right? And that means 2.4 feet per second is the average speed. So that's the answer to question, whatever question this is. It's, I don't know, maybe it's one tiny step more thought requiring than the previous question, but can I go on to, so I'm going to go on to can I maybe get a quick confirmation? I can go on to the next one. Yeah. The next one's velocity, of course, right? Okay. I'm going to look in the chat for a second just to see. And also, of course, I'm doing, yeah, thank you. I love the yes. So nice. Okay. Thank you, Sulady. And thank you. See, I've lost track of who, but thank you, Sulady, definitely. And I think maybe Nora. Oh, it must be Nora because of twice in the chat. Yeah. Thank you, Nora. Thank you, Sulady. Okay. I'm going on to question 6. And hopefully you see too, I know for many of you, this is still going too slow. I understand that. It's going too slow, but yet I still speak too fast, which is a weird thing, right? But hopefully you're also seeing that even if this is too slow for some of you, it builds, right? And the whole thing about physics is the more you really know the fundamentals, the more you can accelerate and start zipping through the harder things on your own. It's just like playing piano. You got to really know your scales, and once you really know your scales or the equivalent, songs are easier. But okay, anyway, so question 6. Now we want to know what's the average velocity from t, woo, hello, equals to t equals 5. And right after this, wait, it's 11:40. I'm gonna, well, okay, let me do this one. So average velocity equals, but notice I hope you all see, I'm still doing the 5-step method every single time. I mean, I'm skipping step 1 because we already said the diagram and fact pattern is true. But other than that, I'm literally, and again, if it helped any of you, if any of you asked me to in the chat, I would write in the margin like DFP, WIQ, GDP. But if you don't need it, I'm not. And again, you don't have to write that in the margin when you do the homework, but you should have it as a checklist, as a rubric in your mind for doing the homework. And again, if you're ever missing anything, we'll write that in the margin, and that's what we mean. But hopefully you're seeing that I'm doing all the steps every time, I believe. So the average velocity is that. I'm going to the next page. Okay. Average velocity is that. Okay, so we know the time here is 5 seconds. Now, it seems to me, well, I'll be really specific. It seems to me that x naught in this case is 4, positive 4, right, feet. And x at the end of the 5 seconds, the final position at the end of the 5 seconds, I believe, is also 4 feet, right? He ends up back to where he went that way, and then he comes back to where he started. So it really does seem to me, not to drag it out, but it seems to me that the total displacement, oh, and I guess we already said this somewhere, but the total displacement for those 5 seconds is just 0 feet, right? So the average velocity, the average velocity in this case is 0 feet over 5 seconds. That means the average velocity is indeed 0 feet per second, right? Which is a little bit interesting if you've never seen this before. I mean, a little bit interesting. Like the average speed for the 5 seconds was, I already forgot, was 2.4 feet per second. So this guy, on average, if he had a speedometer that he was clocking, on average, he's going like 2.4 feet per second. That ain't nothing. But we're saying on average, his velocity is nothing. Even though he was moving like the whole time, we're saying his average velocity is nothing because on average, he got nowhere. Like he literally did for the entire journey. He ended up where he started. He wasn't displaced at all. So on average, how fast was he going? Taking into account direction? Not at all. Kind of interesting, kind of a different concept, right? I mean, and again, it's just English. We're just giving words to the two different concepts, but what we're really saying in physics is like, we should always keep track of both of those ideas of motion. Like they're both, each one has a context in which it does tell us something meaningful. So note here, I'm saying, this result that we just got here can be generalized. It seems to me from here on in physics, for any round trip that we ever experience, we'll know right away the average velocity for any round trip will always be 0. And please note what I mean by round trip. Well, we're in one-dimensional kinematics here. The context is that all motion is taking place on a line, an axis of space. So round trip is an English expression. It doesn't literally mean round. There's no going around anything in one line, but round means if you end up where you started, if you go there and back, your average velocity is necessarily 0. Oh, not your average speed, but your average velocity is necessarily 0 for any round trip from here on in physics. Okay, so that's the answer to that one. Now, I'm going to pause for a second. We have 20 minutes. What I think I might do, let me just look at the sheet, because I think you're getting the idea. And I know some of you, I'm sure, are very itchy just to get to the end of it. What I think I'm going to do now, what I'm going to do now, so we have part 2 and part 3. Of course, part 3 is the most thought-provoking, and it's the most chance of maybe getting, it's very possible that some of you flew through a lot of this, which is great, but then maybe you did get a little stuck or you're not totally sure on part 3. I totally respect that. Also, I keep saying, I don't mean, for some of you, this might not be easy at all for any number of reasons. And there's no shame or blame in that either. I don't think anything in physics is easy. Okay, honestly, I don't think anything in physics is easy except once you've done it and once you understand, in which case everything is easy, right? It's never fair for me to call anything easy because everything for me in physics is either impossible because I haven't done it yet, or if I've already done it, then yeah, it's easy for me. But you're all at different stages. So I just know from experience that a lot of you, if you got this far in science, probably a lot of you are, it's more likely that I'm boring some of you than really exciting you. And so I'm apologizing for that. But if you're not finding this easy, that does not mean you are going to fail the class or something like that. It does mean that you maybe want to be ready to reach out to Professor Walters or me if it keeps being difficult. But anyway, what I'm saying is, everybody's at different levels. As long as you're understanding what I'm saying so far, then that's the important thing. What I'm going to do now, though, so that I don't lose you all to boredom or to like frustration, I'm going to pause now. We have 20 minutes left. I'm going to just like write out the answers to all the rest so you can see if you did it right or wrong. I'm just going to write out the answers. So you wouldn't get full credit for this if you did this, but I'm just going to write out the answers so you can see and so you can have them. And then with whatever time left, I'll try to go over the difficult, ones or answer any questions. But let me just give you the answers quickly now, just in case. Okay, so we're going to, or is that clear what I'm saying? So I'm just going to give you the answers, then we'll talk with whatever time is remaining. Can I get any confirmation in the chat is that okay? Good. Okay, great. I love this class. Oh, I love it. Sounds good. Yuppers. That's great. Poggers. I don't even know that one. Sounds good. Okay, thank you. Okay, I'm totally going to do that. What is pogger? Oh, as in positive? No. Well, that's great. Either way, I'm so behind. I only just learned like OG, that expression, like just like 2 weeks ago. So I don't know any. What is LMAO? That one I know. Maybe so. Okay, I'm going to start thinking about maybe in the chat. Tell me what's poggers. No wonder my sons don't understand me anymore because I don't know anything. Poggers. That's awesome. I'm sure I love it, unless it's profane, in which case I probably privately love it more. Okay. All right. So here we go with answers. Bear with me. You're going to pause for a sec. I'm about to get to part 3 where we might want to talk. I'm just going to pause. So these are the answers for part 2. Pause for a second. Just note, I sort of put little plus signs on on question 2 and 4. I'm not saying you have to do that. Like, it's like math. I mean, if there's no sign at all, we do assume it's positive, but I'm just saying it because these questions are a little weird. Like the answers to displacement and distance and the answers to velocity and speed happen to be the same ones here. It's sort of redundant. It's the same answers because it happens to be the case that for all of those first 4 questions, the instructor is moving to the right. So there's no real obvious difference in the answers. Like there would have been if he'd been going to the left, then all the scalar answers would have been positive and all the vector answers would have been negative. Here, everything's positive. So I'm just putting that little plus sign there just to highlight that that is a concern with, but those are the answers. Then, yeah, same thing with average speed and average velocity were both 3. Okay, so they're kind of a little bit stupid maybe. So that's part 2. I'm going to go to part 3 now and write the answers. Then I'm going to try to explain anything. I assume probably it'll be in the part 3, but those are but certainly if you have any questions about part 2, let me know. But and I'm going to flip the sheet if that's okay also. But you can let me go back at any time. You could tell me to go back at any time. Also, of course, this will be in a PDF that you'll get, blah, blah, blah. And also this one, I might write out a little bit of work here, even from my second. Okay. So this is question 1. At t equals 7, what does x equal? Right. So what's the position at the 7, 7? So I guess I am writing out a little bit of work for this, partly for my own sake, but partly for yours. This is not complete work, but okay. I'm going to pause it. Okay, I think we're on time here. I'm going to talk about this work that I just did in a moment. Hopefully I'll have time. I'm going to say your work might not look anything like that. It probably doesn't look quite like that. I do want to make comments about it. You obviously have to show work of some way, but what I would like, if you look at my work, ultimately, I'd like you to see that what I wrote hopefully is consistent with steps that you did in your brain, even if you didn't quite think of it that way. I do think that's the answer. And I do think if you got this one is now just hard enough, like welcome to physics now. I'm not saying it's crazy hard, but I'm definitely saying it's just hard enough that if you got this one wrong or you got stuck, definitely no shame, no blame, for one thing. Number two, if you did get it right, yay, like you should take a moment to be proud of yourself, like seriously, because it's not a joke. It's a leap from everything we're saying. But no, on the other hand, and I do believe the answer is positive 1 foot. Like I do believe that's the answer. There's a million other ways you could have gotten it. Like your work could look very different from mine. But I would say that if you got it right, you actually must have thought about it in a way that is captured by what I wrote. You just might not have thought of the equations that way. Let me put it one other way. Please note, and I will talk about it in more detail in a second, but please note, even if all of a sudden it looks like I did all this physics here, it might look that way to somebody like, oh my God, wait, he's like doing stuff. All I'm doing is algebraically rearranging the one and only one equation that we have so far. Like, please note, whether you found this question easy or hard, either way, there's no new information required for this question. It is just our old information that we have. The one equation that we have, average velocity equals is defined as displacement over time. And I just carefully rearranged it to apply it to the situation. That's what's going to happen for the rest of our lives in physics, even when physics seems really hard, or even when it seems unfair, which of course it will seem that way from time to time. I'm kind of almost defensively saying, please note that this one might have been a little hard, or suddenly all the work I just did might seem like a leap, but it's not actually a leap off the page. It's not actually unfair. It's just hard if it is hard, right? All I'm doing is rearranging information that I already have. And that's what we do in physics. That's what we do. And in fact, we don't even get new information as much as we do in biology or chemistry. There's not a lot of information in physics. There's not a lot to memorize. There's not a lot of equations. There's more than one, of course, but each next step that we ever get in physics will be built from the last. It's always just rearrange what we've got and more is produced. Rearrange what we've got and more is produced. Rearrange what we've got and more is produced. So that's what makes it both easier and harder sometimes. But as long as you know that's what's going on, that there's never new information really, as long as you know that can help. But okay, and I will answer questions in a second just because we actually are sort of on track here, which is pleasantly surprising. I'm just going to scroll out question 2 now. I mean, unless you actually, okay, no, this is not the end. Okay. Oh, did I lose you? No. Okay. I'm going to just scroll out the very last question, and then we'll see what questions there may or may not be. Sorry, let me just get so I'm doing the last question. Okay. Oh, and it's supposed to be feet. If I said meters, oh, yeah, it's feet. Okay. Wait, I feel like I'm doing something wrong. Actually, hold on 1 second. I'm sorry. 3, 2, 4. Okay, this is a weird way to end class. So we have 7 minutes left of class. I'm going to say right now, and again, I'm ready to answer questions about question 1 or this one. This is the answer I get for question 2. And I don't think I made a mistake, but I have to admit right now, I don't remember that. That seems like an unfamiliar answer to me just from past memory. So there's a little part of me that feels like maybe I did. So I guess I want to ask in the chat, did you guys get, all right, let me go in order. We have 7 minutes. Let's first start with this. How do you feel about question 1? Can anybody put in the chat whether they either, if you got that answer, if you feel okay about that word, so maybe I made a mistake right here. Okay, hold on. Okay, so thank you. All right, so maybe I did make a mistake right here because something does look, all right, sorry, let me see. I'm sorry. Thank you. I'm glad we're checking. Hold on. Yeah, phew. Okay, I'm glad we're checking. What did I do? My bad. I'm sure you're right, actually, because something was unfamiliar about the last question. Okay, x equals 2. Yeah, okay, I'm going to change. Thank you. I'm changing x equals at t equals 5. Oh, I think I see what's happening. Hold on. At t equals 5. Where is it? Oh, sorry. Oh, I see what I did. I'm sorry. T equals 5, he's at 4. At t equals 5. I see. I'm sorry. Sorry. What am I doing? Sorry, something is. Oh, I'm looking in the chat. Sorry. Oh, -2. Right. Yeah, -2 does. Hold on. Sorry. Bear with me for a second. No, I know you guys are right. I'm just looking for what my error was. Oh, yes, of course. Oh, yes, I'm sorry. And I see where I made, just sorry. Okay, I'm going to correct you. I totally agree, and thank you. I'm glad we're having this moment. I'm glad we still have 3 minutes. First of all, and thank you. And you all get me. I get a D. You all get A's. Yes, I agree that the answer is -2, and I just corrected my work. And my mistake was I had that the average velocity was +3 when in fact it's -3 because he's going backwards at this time. Yes, he's going to the left during this interval is -3. So that's my work for that. And hopefully there might be more questions or more, but I apologize. Yes, -2 is the answer. And so I just want to correct, therefore, my answer in the last one. So the answer is, so this is -2. And therefore, right. And this is the answer I thought I remembered. Yes. Okay. So this ends up being 0. Okay, so my apologies and thank you for those of people who spoke up in the chat. So I'm, okay, phew, yes, thank you. And thank you again, and I'm sorry, and thank you, and I'm sorry. And I wish there was one word in the English language I could cover thank you and I'm sorry. It would be like having a lisp, like sorry. But yes, all right, cool. So, and if that does that mean, I know we have like 2 minutes more, but if those are my final answers, and I knew something was wrong. So my answer for the second to last one's -2. And notice, again, you might have just thought of it in English, but what I really did was I just rearranged the average velocity definition. And notice X and X naught mean final and initial for whatever interval I'm looking at, right? So in this case, I was looking at the interval from 5 to 8. So my initial position was wherever I was at 5. And my final position was wherever I was at 7, because that's what the question's asking about, right? Like hopefully, and same thing. So I'm just flipping back and forth. So -2 for the second to last one, 0 for the last one. Hopefully the other ones were right and clear. It's 12:04. Again, as soon as this is over, I mean, I have another class coming in. As soon as it's over, I'll post the PDF in a few hours or a day. I'll upload the video. You guys will be in Westport on Monday with Professor Walter. She's awesome. She can't wait to see you. You could text me or email me if there's any issues, blah, blah, blah. But other than that, I'm going to sit and just wait if anybody has any last questions. But other than that, thank you so much and goodbye. Thank you. Have a nice day. Thank you very much. Awesome. Thank you. Have a great day. Thank you. Awesome. Yes. Enjoy your day too. Thank you. And I'm going to turn off the record. Thank you. Awesome.